Hey guys, today we're going to talk about something that is so majorly important. And we're going to teach you how to actually take a trinomial and factor it. So we're going to break it into two categories. So today we're going to do lesson 8-6, factoring trinomials. And we're going to look at them that have the quadratic term, that's the first term, is going to have a coefficient of 1. So we're looking for ones that look like this: x squared plus bx plus c, okay? Now, we are going to do what is called a combo method, okay? So I'm going to talk to you about the combo method. Now, your notes should take you 2 pages today. It probably is going to take me more than 2 screens, okay? So the combo method, we're going to learn something called the product sum game. Now this is a way to solve this problem. I may illustrate one a different way, which is listing out factors and then trying to find the combination that will give you the right middle term. And so that's what the product sum game does, but you're not listing all sets of factors for those coefficients. Once I play this game, then I'm going to take the information I find and I'm going to take my trinomial and I'm going to turn it into a 4-term polynomial so I can factor by grouping. Okay. So let's kind of go through our, I'm going to change colors here. So this is the one that we're talking about, looks like this. And I'm going to go ahead and make sure that we have a term for each of our pieces here. So the first guy is called the quadratic term. Okay. The second guy with just the x is called a linear term. And the guy that has no variable attached, he is your constant. Now, sometimes we can have 2 different variables in the front and in the back, and then we'll have a blend of variables in the linear term. So what's important about the words quadratic and linear is the kind of graph you would get. So with the quadratic term, anytime you have an x squared term, you're going to get that parabola shape that we talked about in the notes on Tuesday. And if you have just an x, then you're going to get a line, because it's a linear equation kind of thing. Now, again, what we're going to, in all of the examples we're going to work on, is that coefficient in front of the x squared, the linear or the quadratic term, is a 1, okay? Now, a couple of things just to remind you is that b and c are numbers, except no 0, okay? And that's what this process is. If there is no constant, then you're just going to be factoring out a GCMF if possible, okay? So I'm actually going to go to the next page because I want to have ample room to do what I want to do, but you guys should be able to fit all of the rest of the information that's on the second slide is going to be on the first one. So what I want to do is kind of talk about this idea called the product sum game. Okay. So we're going to, throughout this process with the product sum game, we are going to utilize an example of x squared plus 4x plus 3. So our goal is we're going to try eventually to get this down to 2 binomials. Now it could be more because we could have the difference of squares and we would need to factor that, which we'll talk about in subsequent issues. So what are my steps? Step 1, we're going to multiply the quadratic coefficient which in our case is a 1, by the constant. And we're going to call him the C value. Okay. So this is where we get the term product. This is that when you multiply, you're going to get the product of the product sum game. Okay. So I'm going to pull down my two numbers. In our case, we've got 1, and we're going to multiply it by the constant, which is the 3. Okay, and then we get the answer is 3. Okay. Then we're going to identify the linear coefficient. So the linear coefficient is going to be the blue color, okay? So for us, that's going to be whatever that B value is. So for us, we're going to say the linear coefficient is equal to 4, okay? Because that's the B value. Now again, remember, your trinomial has to be in descending degree order, or this won't work. Maybe I should put a little warning up here. Must be in descending degree order. Okay? So, step 3, we're going to create a lattice. No, create what I call a lattice, which is a fancy way of calling a big X, okay? So we're going to create a big X. Bump, bump, okay? So lattice comes from, I have fencing in my backyard where it's kind of like this interlocking X's. And it just interlocks all like this, and it's big enough to let plants kind of go through, but small enough that my dog can't get through, kind of thing. Okay. Oh, I forgot. That B guy, he is going to be the sum number in the product sum game. Okay. So fourth thing is we're going to place the product, which is the A term, which is 1 in this case, times the C term. We're going to place the product at the top, the lattice, or X, and the sum at the bottom. Okay, so I'm going to take those numbers, I'm going to put them in. So I'm going to put the product number, which I'm going to put at the top, is going to be 3, and I'm going to put the sum number, which is the 4, at the bottom. Now, we also want to include the signs because we need to pay attention to them, okay? So I'm going to write here, include signs. So then, here comes the game part. Think of two numbers or let's use the word factors. I like that word better. Think of two factors that multiply to make the product number and add to give the sum number. Okay, so you can think of, oh, that's supposed to be a plus up there, I'm sorry. Should be +3, okay. So you could be thinking about these guys over here and go, okay, well, let's see, 1 times 3 is 3, and that's all I've got. So this is the multiplying part, and then we're gonna do the adding part. So if I take those two numbers and add them, I get 4, which is exactly what I need, okay? So then what we're going to do is place these factors on the sides of the lattice, and again, include signs. So I'm going to redraw that lattice. So we've got the +3 at the top. We've got the +4 at the bottom. And we came up with a +1 and a +3. The order of those two do not matter. Okay, the 3 could come first and the 1 can come second, so the order does not matter. Okay, now we're going to involve the second part, which is the factoring by grouping. So we're going to turn the trinomial into a 4-term polynomial by splitting, and put that in quotes, should put it in color too, splitting the middle term, or the linear term. I'll say middle. I've seen it written this way. So we're splitting the middle term into 2 terms using the factors from the game. Okay. So in other words, we're going to take these guys, and instead of having, let me go back to a different color. X squared plus 4x plus 3x, 3, blah, English. We're going to keep the x squared, keep the 3, but then we're going to split the 4x into 2 middle terms using the values that we have in our game. So we have a +1x and a positive 4x. Okay, and then the last thing we're going to do is factor by grouping. So these two have an x in common. These two have, I don't see anything they have in common. So we have to come up with something, so we can always say it's 1. This is going to give me x times the quantity, x plus 1. And then we're going to pull out a positive 1. And then, oops, I did that wrong. I wrote 4x and it should be 3x. Hello. This is why when you're not here with me, I make dopey mistakes. Let's try this again, shall we? Let's go back. That should say 3x. And then you can see that they do have something in common. They have a positive 3, positive 3 in common. So I'm going to pull out that positive 3. And 3x divided by 3 is x, plus 3 divided by 3 is 1. So then we get our miracle, and we get x plus 1 times the quantity, and then those two coefficients form their own binomial, x plus 3. Okay, so that's, and it doesn't matter if I write x plus 3, or x plus 1 times x plus 3, or x plus 3 times x plus 1. It doesn't matter. All right, so we're going to go on to the second page of our notes and actually do our examples. So the title is Lesson 8-6, Factoring Trinomials. Factoring Trinomials. And this is x squared plus bx plus c. Okay, so directions are going to ask us to factor. So again, you need to start with descending degree order. If they aren't that way, you got to do it. Off to the side, I'm going to play the game. So I need factors of that product. So 1 times 20 is 20. And then grab him, goes down here. So now I need to come up with factors. Let me get my signs in here, positive and positive. Things get a little bit more complicated when we get negatives. Obviously, that always complicates everything. So I need to think of factors of 20 that would multiply to give me 20. So I have 4 times 5, 2 times 10, 1 times 20. Yep, that's pretty much it. And then I'm going to add. So this is our target number. We multiply to get him, and now we add to see what we get. So we get 9, we get 12, we get 21. And this is the one we needed. So those are going to be my two numbers. Just put them over here. We've got a positive 4 and a positive 5. So then my polynomial becomes x squared, and then I'm going to put in my two guys here, plus 4x plus 5x, and then the plus 9 at the end. Okay, and then I'm going to factor by grouping. These two have an x in common, and the second two have a positive, wow, nothing. So positive 1 in common. Oh, my brain is not working. Sorry. Let's try this again. This is supposed to be 20. Product number. That's what I started with. Remember, it's that guy. Those guys don't change. So try that again. Those two have a positive 5 in common. I'll get there eventually, my friends. So we get x times the quantity, x plus 4. Then we're going to pull out the positive 5 times the quantity, x plus 4. The miracle happens, and we get x plus 4 times the quantity, x plus 5. Okay. Another one. We've got x squared minus 8x plus 12. Okay, so we've got product, 1 times 12, that's going to give me 12, and then we're going to grab the guy in the middle. There's negative 8, he's going to go here, so let me remind myself this is a positive. So because I have a positive 12, that means the signs would be the same, but because of the negative, that means they're going to be two negatives. So let's see, negative 3, negative 4, negative 2, negative 6, negative 1, negative 12. And then if I add, I'm going to get negative 7, negative 8, and negative 13. So this is the right combination. So these are the ones that I'm going to use in my polynomial right there. Okay, so I get x squared, and then I'm going to grab, let's put them in here, negative 2, negative 6. So we're going to get x squared, and then minus 2x minus 6x. So notice because I'm splitting the negative 8x, x is attached to both of those middle guys, and then I'm going to have the plus 12. Okay, the guy that was at the end. And then we're going to go ahead and factor by grouping. Let's see, these two have an x in common, and here comes this part gets complicated. Because of him being negative, I have to pull out a negative. Okay, you just have to do it. And then you're going to 6x and 12 have a 6 in common. So that's going to give me x times the quantity x minus 2, and then I'm going to pull out a negative 6, and that's going to leave me, let's see, negative 6 divided by minus 6, it's going to be a positive x, 12 divided by negative 6 is going to give me a negative 2. So then the miracle happens, and I get x minus 2, and then I get x minus 6. Okay, and that's my answer. I didn't box that up, or this one. Okay, and then the next one, we've got x squared plus 2x minus 15. So we've got our little lattice going. We got our product, and we get a negative 15. And then we're going to pull out our term, we get a positive 2. So now where this gets strange is, how do I get a negative product? That means my signs have to be different from each other, so I'll end up subtracting them. So let me think of combinations I could have. So I could have 3 and negative 5. I could have negative 3 and positive 5. I could have 1 and negative 15. I could have negative 1 and positive 15. Okay, so then I'm going to talk about if I add them together, what do I get? Let's see, I get a negative 2, I get a positive 2, negative 14, and a positive 14. Okay, so the combination I need goes with negative 2. So this is my grouping. So I have a negative 3 and a positive 5. Now, I'm going to suggest that you put that negative one always on the left, if there's only one of them, because you want to put him in first, because you want that middle term to be positive. Okay? That's going to make your graphing or your calculating a lot easier. So here we've got the x squared, we've got the negative 15 at the end like that. Now we're going to put in those two middle terms. So put the negative 3x, positive 5x. Okay? Trust me on this one. So let's see, these two have an x in common. These guys have a positive 5 in common. All right, let's see what happens. So when I pull out the x, in this first group, I've got x minus 3. And then I pull out a positive 5. Factor it out. Pull out sounds weird. And I get x minus 3. So I got my miracle. So my answer is going to be x minus 3, and then times the two combined, x plus 5. Now, you can always check all your answers by just distributing, multiplying out the two binomials, making sure you end up with the original. And that's a really important thing to do, especially when negative starts getting involved, to catch any careless mistakes you make. All right, last one. We've got x squared minus 2r minus 24. So we got a lot of negatives in this one. So when we multiply, let me get my lattice going over here. Well, let's bring them a little closer. Oops. So when I multiply 1 times negative 24, I get negative 24. And then I'm going to just grab the coefficient of the linear term, which is negative 2. So now I'm going to figure out, so again, to get a negative product, I'm going to have one positive, one negative. So let's see what I could come up with. Oh, there's a lot here. I could have a 4 and a negative 6, a negative 4 and a positive 6. I could have a 3 and a negative 8, a negative 3 and an 8. I could have a 2 and a negative 12. I could get a negative 2 and a positive 12. I could get 1 and a negative 24, and I could get a negative 1 and a positive 24. Now I got to tell you, the factors that are 1 times the number itself, they get overlooked all the time. So if I add these, let's say I get a negative 2, a positive 2, a negative 5, a positive 5. Negative 10, a positive 10, a negative 23, and a positive 23. So the combination I'm looking for gives me a negative 2. So that would be this grouping right here. So I'm going to put the negative first and then the positive. Okay. So now this is going to get split into x squared in the beginning, minus 24 in the back, and then I'm going to grab those two terms. So we're going to do negative 6r. Wanted to do x, I'm so used to that. And then plus 4r. And then I'm going to factor by grouping. These two, oops, I put x in the front and r. That is so funny. Maybe I couldn't even read what I was writing. You know what, let's just do this. Let's change the r to an x. That'll be easy. That wouldn't work if it was two different variables, would it? Not like that. Oops. Okay, I think I've messed up on every problem. Lovely. So we get an x, so it's going to factor into x times the quantity x minus 6. These two are going to have a positive 4. And that's going to give me an x minus 6. So I get my miracle, x minus 6, and then the second binomial is going to be x plus 4. Okay? And there you go. All right, good luck, guys. See ya.